The mass analyzer is the heart of the mass spectrometer. It takes ionized masses and separates them into based on mass to charge to mass ratio. There are 6 mass analyzer. First one, quadruple mass analyzer, time of flight, which is known as TOF mass analyzer, magnetic sector mass analyzer, electrostatic sector mass analyzer, quadruple ion trap mass analyzer, and ion synchron resonance. Quadruple mass analyzer. This is the most common due to simplicity to use, sensitivity, and quick scan speed. So basically, quad is four rods that have combinations of radio frequency, which is known as RF, and direct current DC voltage applies to them. Combinations is chosen to allow only ions with specific M over Z or a range of M over Z to transmit through analyzer. So this is a low resolution analyzer. The advantages of quadruple mass analyzer are classical mass spectra, good reproducibility, relative small and low cost system. The limitations such as limited resolutions, peak height variable such as functions of mass, the mass discriminations. Time of flights, or also known as TOF, is a relatively simple mass spectrometer, typically quite sensitive and fast. The improvement in the technology have increased significantly the resolutions of these instruments by use of reflectron, increasing path length, and use of pulse voltage in the source. So TOF is used to separate ion of difference M over Z in time domain over a fixed path distance. So measure time of an ion takes to travel a specific distance with a specific kinetic energy. The larger M over Z take longer time to travel than the smaller M over Z. So based on velocities, the lightest ion arrive first, followed by the medium ions, and lastly heaviest ions. The advantages of TOF, it is the faster MS analyzer, high ions transmissions, highest practical mass range of all MS analyzer. The limitations, fast digitizer used in TOF can have limited dynamic range. The magnetic sector instruments are made of electrics and magnetic field that band a beams of ions travel at relative high energies. Once it is the most popular analyzer for high resolutions analysis, but have gone out of favor because of lack of sensitivity with scanning, pace required, and complexity of actual running them. Difference between magnetic sector and TOF is a magnetic field is used to separate the ion. As moving charges enter a magnetic field, charge is deflected to a circular motion of a unique radius in directions perpendicular to apply magnetic field. So the ions in magnetic field experience two equal force due to the magnetic field and also the force due to the centripetal force. The advantages of magnetic sector instruments are classic mass spectra, very high reproducibility, best quantitative performance of all mass spectrometer analyzer, high resolutions, high sensitivity, high dynamic change. The limitations are it is not suitable to use with MALDI. The cost of mass analyzer is higher as compared to other mass analyzer. The electrostatic sector mass analyzer is similar to TOF analyzer in that it separates ion while it's in flight, but it separates using an electric field. It consists of two curved plates of equal and opposite potential. As ion travel through electric field, it is deflected and a force on ions due to the electric field is equal to petal force on ions. Ions of same kinetics energy are focused, and ions of different kinetic energies are dispersed. Quadruple ion trap mass analyzers employ similar principle as quadruple analyzer. It uses an electric field for separations ion by mass to charge ratio (m/z), made with ring electrodes of a specific voltage and grounded end-cap electrodes. The advantages of quadruple ion trap mass analyzer are high sensitivity. It is a compact mass analyzer. However, the limitations such as poor quantizations, very poor dynamic range, and require many parameters such as excitations, trapping, detections conditions, comprise experiment sequence that define the qualities of mass spectrum. Ion cyclone resonance (ICR). In these techniques, the M/Z ratio of an ion can be experimentally determined by measuring the frequency at which the ion processes in a magnetic field. An ion trap that uses a magnetic field in order to trap ions into an orbit inside of it, no separations occur. Rather, all ions of a particular range are trapped inside, and an applied external electric field helps to generate a signal. So the cyclotron's frequency of ion cellular motion is mass dependent. This is an illustration of ion cyclotron's resonance occur in the mass analyzer. The advantages of ion cyclotron resonance: highest recorded mass resolutions of all mass spectrometer, powerful capability for ion chemistry and MS/MS experiments, well suited for use with pulse ionization such as MALDI. The limitations: it has limited dynamic range, strict low pressure requirement mandates an external source for most analytical applications. Artifacts such as harmonic sideband are present in mass spectra. Many parameters, for example, like excitation, trapping, detections conditions, comprise experiments sequence that define qualities of mass spectrum.